Hello National 5, it's Mr. Neil here. In this video we're going to be focusing in on database design. In particular we're going to be looking at a database structure and entity relationship diagrams. This is one of two videos where I will be looking at database design, and in the second video I'll be looking at data dictionaries. With regards to entity relationship diagrams, you need to be able to produce entity relationship diagrams that indicate entity names, attributes and relationships. That means by the end of this video you'll be able to explain the structure of a database in terms of tables, fields and records, as well as entities, attributes and instances. You'll also be able to produce an entity relationship diagram that identifies all the entities and attributes within a database, identifies the primary and foreign keys within an entity, and identifies and describes the relationship between two entities. A database can be defined as a structured collection of data around a particular topic. For example, Amazon. The Amazon website is a database of all the products that they sell. Websites like Footbin, where you can pick FIFA players, they're databases and we have lots of different information about them. Amazon and websites like Footbin put a nice user interface on the front end of their database so they look nice to the user. For our purposes at National 5, we are not worrying about the front end and how it looks, we're worrying about how it's designed, built and how we use it. Databases consist of entities. An entity is something that exists. It's something that exists in real life. And it's something that we want to store information about. For example, we might want to store information about a student, or we might want to store information about a school. Each of these entities have attributes. And an attribute is a piece of information that we want to hold about an entity. So if we think about a student, things that we might want to store in our database about that student is their first name, their surname, their date of birth, and their registration class. For schools, we might want to store their school name, the head teacher of that school, the phone number of that school, and the website of that school. So the entities are student and school, and the attributes are the pieces of information we hold about these entities. When we come to implement it, it is likely the information will look like this. We have got our two entities, student and school, and within our student entity we have got our attributes first name, surname, date of birth, registration class. Within our entity school we have got our attributes name, head teacher, phone number and website. We can see here that an entity becomes a table when we implement it, and an attribute becomes a field, a specific piece of information. All these attributes, when they come together, make a record, and that is all the information about one person or thing. Sometimes you might hear a record referred to as an instance of an entity. Each entity within our database needs a field that we can uniquely identify a record with. So if we take our student, we need to figure out what attribute we can use to uniquely identify each student. For example, first name. Well, it's unlikely first name is going to work because there could be two Rebeccas in our school, and that means it's not unique. Surname. Chances are there are two students with the surname Smith. Date of birth. Chances are there's more than one pupil born on the same day. And with registration class, there's definitely more than one person in a registration class. So none of these are going to work. So let's add a field, for example, student ID, that we can use to uniquely identify a student. If we look at our other entity, school, we have name, head teacher, phone number and website. Whilst the phone number could be a primary key, it's a very long field to be a primary key. So we're going to add in one called school reference. So to uniquely identify a school, we can use the field name school reference. Now that we have these two tables, we need to consider the fact that there's a link between these two tables, because a student attends a school. So how do we go about linking these two tables together? To link the two entities together, we use something called a foreign key. This is the primary key from one entity included in another. So let's look at our two entities. We have got student with the primary key student ID, and we've got school with the primary key school reference. So one of these is going to be our foreign key. How do we work out which one is the foreign key? Well, the easiest way is to describe the relationship between our two entities. So if we think about a student, how many schools does a student attend at once? And the answer is 1. One student attends one school. If we think about a school, how many students does a school have? And it's many. A school has more than one student. So in that case, we can say the primary key from the school table goes in to our student table as the foreign key. And the reason we can say that is because the many is next to the student table. And that tells us that this is the table with the foreign key in it. And as the foreign key is the primary key in the other table, it has to be school reference. So we take school reference and put it into our student ID. Now that we've identified the link between the tables, we have essentially produced what we call an entity relationship diagram. And an entity relationship diagram illustrates the structure of any database. It provides a method of showing us the entities, attributes, and relationships within a database. It will show us all the entities, all the attributes, all the primary keys, all the foreign keys, and all the relationships between our entities. So let's have a look at a full entity relationship diagram for our case of the school and the student. So we start with our two entities, and then we add the attributes for each of our entities. Once we've added our attributes, we then need to consider our primary keys, and we indicate that student ID and school ref are primary keys by underlining them. So the underline here tells me that these are our primary keys. Now we've got a primary key, we need to add in our foreign key, and you'll recall from earlier we said that school ref needs to go into the student table, and we indicate that it is a foreign key by asterisking it. We then need to draw the relationship between the two tables, and this is where we draw a straight line, and where we have the foreign key, we draw a crow's foot. And if you tilt your head to the side, it kind of looks like a sideways M, and that symbolises many. We then need to write in the relationship. So one student attends one school has many students. And you will notice that the many, the crow's foot, and the foreign key are all linked to the same table. And that way you know your entity relationship diagram is correct and you've correctly identified the relationship between them. I find this method of producing an entity relationship diagram messy, so I opt for this method, where again we have our entity, student and school, and underneath them I have listed the attributes, identifying the primary keys and the foreign key. I've then drawn in the relationship and I have described it. So if you were to produce either of these versions of an entity relationship diagram, they would be correct. So in this video, I have covered the structure of a database in terms of tables, fields, and records, as well as entities, attributes, and instances. And we've looked at how you produce an entity relationship diagram. What I'd like you now to do is have a go at producing an entity relationship diagram for N5CS. So you have to produce a full and complete entity relationship diagram. So that will identify the entities, the attributes within those entities, the primary keys, the foreign key, as well as identifying and describing the relationship between those two entities.